Welcome to Programming Rainbow. In this video, we will start the series of the Beginner's Guide to SDL2 in C. This is an updated version from the original. Just turn this down a little bit. Sorry. Let me try that again. I don't want to hear myself so loud. Welcome to Programming Rainbow. In this video, we'll start a new series of Beginner's Guide to SDL2 in C. This is an updated version from the original, and it has a bunch of new features and hopefully some better code and some better explanation over the original one. So if you want to follow along with this video, you can go to github.com, Programming Rainbow, and this will be called Beginner's Guide to SDL2 in C, updated. Okay, so there's still the original version on GitHub, but this is the updated version. All right, so you can git clone this repository. There is some explanations here on how to do it in Arch Linux, by the way, with Pacman, and how to do it in macOS with Brew. So there's some explanation there. It's pretty simple. You can use the makefile if you want. You don't need anything special for this video. You just need SDL2 installed. You need some kind of text editor. It doesn't matter what it is, and a terminal. Okay, so if you've opened up the code, you can check out the final project by just, you can do a make clean run or something like that, or release run, however you want to do it. And it's going to build the project. So this is the final project. And there's a couple things going on here. We can press the space bar to change the color. We can resize this window, and it keeps the right aspect ratio and it resizes it as it needs to be. Or we can make it bigger. And we can also add, we have our FPS. It's locked to 60 right now, but you could change it, and it would try to, if your hardware is available, I could set it to like 10,000, but it'll probably only run up to like 5,000 or something like that. But right now it is locked at 60 FPS, and this is moving by delta time. So if I let it run faster than 60, these items will still move around the screen at the same speed because we're using delta time. Okay, and we also have music. If I press the M button or release the M button, we also have sound effects. So if I press N, we get that, and we also get C every time we change the color. And we can watch the position of this SDL move around. Now, these are text kind of objects that I've created, and whenever you change the string that's in them, it regenerates the text object, even with the bubble around it and everything. And depending on how you've anchored it, it's going to stay in that position. So that's really nice. You can just kind of use this text module and drop it into any of your projects, and now you have text. And you can you can change the color of the text. You can change what string is in the text, all that without recreating the actual text object. It'll just regenerate its own image internally, and it's rectangle in how it's done. And depending on how you set the anchor point to it, it'll, you can see this one is anchored on the top right, so it grows left. This one's anchored on the top left, so it grows right. This one is centered, although we're not seeing it because we're actually just locked at 60 FPS. It is displaying what actual FPS I am getting right now. It just happens to be 60. Okay, so that is the final project. So there's a whole bunch of stuff in there, and we're just going to get started. So the first thing I'm going to do is just show a little, hello world thing, and we're just going to build from there. So I'm going to take the SRC directory, which is where we were building the source from, and I'm just going to rename it to like SRC2. What's in these directories is the source code that you'll find from each video that we're working on. So by default, the makefile that I'm using compiles what's in SRC, but you can tell it to compile a different directory. But for this one, we're just going to use source, and we're not going to use the makefile anymore. So I'm going to create a new directory. It's going to be SRC. And inside of there, I am going to create a new file. We'll call it main.c. And in here, start right there, we're going to do include, and we'll do stdio that. And I'm just making a simple main function. It takes no arguments, so it's just going to be void here. You don't have to put void in, but I use strict compiler rules. So if I were to leave the void out, depending on how strict my compiler is, it'll complain about that. So you can do puts. So hello from stand out. And we can say printf. So hello going from standard out, and we'll put a new line character on that one. And we'll do printf. And we'll do hello from standard error. And I've forgotten again to put the first parameter here needs to be what file you're sending it to. So this will be std error. And we'll just do a return exit success. That'll work. I think this is from standard lib. Yeah, it's this exit failure and exit success is defined in standard lib. I just want to use that because I don't want to use 0, 1. I want it to be, depending on what platform you're on, use the correct one. Okay, so down here we can say GCC, and we can say source main.c, and the output is this -o, and then main is what we'll call it. And now we can run it, main, and we get hello from standard out, and hello again from standard out, and hello from standard error. So we can see that they're standard out or standard error by sending one of them to null, dev null. So we'll send standard out to dev null, which is 1. And we only get the error message this time. And if we were to send the error, we only get the standard out messages. Okay? So any error messages I'm going to be sending to standard error, and any normal messages I'll just use normal printf or puts or something like that. So in SDL, if you go to the website, they have a lot of information. So I'm going to be using this API category. So if we click on that, we're going to get to the SDL3 version, but we're working with SDL2 today, so we are going to go to the SDL2 version right here. And you can click on these different ones, and like this one, it's going to talk about initializing and shutting down, but it's going to use this function here, which is SDL init. And SDL init takes a parameter, which is a flag. We can see the flags down here. And the flag we're looking for is the init video. And it returns an int. And if we look here, it says 0 success and a negative on failure. And if it is failure, we can use this function right here to get a string out of whatever that failure was. Okay, so let's implement this first function here to bring SDL online. And to use this function, we are going to need the to include SDL2, and it's going to be SDL.h. So if you're on macOS, well, let's just show where it is for any of these. So we can use package conf, and we can use C flags SDL2, and it's going to show us where it is. So if you're on Linux, it should be here. It should be in the SDL2 folder, and that's where we're going to find the SDL.h file is in the SDL2 folder. That's why it's here, SDL2, and then SDL.h is what we're looking for. So it's here. But if you're on macOS, it's going to be right here. I've set this .clangd for people on Mac, and this is opt homebrew include. If you installed SDL2 through homebrew, that's what you're going to see. So this will allow Clang to be your LSP on Mac, and it doesn't affect anybody on Linux, so that's fine. Okay, so I've included this header. Now let's make sure we implement this. So since we know we're getting 0 as a good and any number, like a negative number, as a bad sign, 0 is false, right? And any other number is true in an if statement. So we can just wrap this function in an if statement. So we'll just do that. So we'll say if, we'll say SDL init. And so if anything comes out of this, something bad happens. So this is our bad pass. So we're going to use this error printing here. I'm just going to cut that, put it in here. And we did have a flag up here, and it was init, SDL init video is the flag that we want to use. But later on, we may use different flags. So I want to make this where it can be changed, but I want to hold it in one place. So I'm going to use a pound define because I'm going to keep all my global pound defines in just one place. I don't need to look through my code if I need to change them later. So say fine, and I'm going to call this SDL flags. And the specific flag I want for this video is init video. But later on, we can always pipe this with, with say audio or something like that and put it in parentheses. But for right now, it's just video. That's all we need. So I'm going to put that down here. And if we ever change that, we don't need to go searching for where this function is now. Okay, so if this does fail, I want it to exit out. So we'll say return exit failure. Okay, so this should bring SDL online with the flags. And if it does error, it's going to have an error message. So let's set that error message to something that makes sense. So let's say error initializing SDL2. And we'll put a colon, and then we'll bring in a string. So we'll do a %s on that, and we have the new line character there. And now we'll get that string from SDL, whatever it was. So it's SDL get error. And that's going to return whatever the error string is in SDL. And so it'll put it here, and we'll have this whole printout. So that is SDL online. And to take SDL offline, we use the other function that goes with it, which is SDL quit, and it doesn't take any parameters and it doesn't return anything. So I'm going to put it down here. SDL quit. Okay, so we're bringing SDL online and now we're shutting it down, but we haven't created a window or anything yet. So let's go work on that. So to create a window, we use SDL create window, and we're going to take a string for the window title, and we're going to take an X for the X position, Y for the Y position as ints. Then we're going to take a width, height, and some flags. So we can let SDL calculate where the X and the Y is going to be for us if we give it a width and a height. So that's what I'm going to do. I'm going to use SDL window pause centered for both the X and the Y. And I'm going to define the width and the height myself, and there's flags. So the flag that I want to use is the flag on this video is just the shown flag, but later on we'll use other flags with it. So SDL shown, and I'm going to put this in window flags. I'm going to call it window flags, and I'm going to drop this one in there. And I'm going to have a window width and a window height for W and H. And these I'm going to use the SDL the preprocessor for these two, the one that's already defined for us. Forgot the name of it, the macro. Okay, so here's our function right here, but we do need to, implement a couple things here. So we do need a string, and I'm gonna hold that up here again. All these defines are going to be kept in one spot always, so I can always get to them. It's just going to be kind of the things that need to be global for the setup. So we'll say window title, and we can say open window. I also want a window width. We'll say 1280, and a window height for 720. You can choose whatever numbers you want, but for this project, it's going to be a 1280 by 720. Okay, so we got window width, window height. We have these flags, so I'm going to put them up here with the flags. And the flag that I wanted was the window shown. I don't remember exactly how it's worded. SDL window shown. Okay. Okay, so I think that's everything. So now we can go into here where this is. We can use our title. So this would be window. Oops, I did it. One of these days, I'm going to get it right. There it is. Okay, so for the X and the Y, I'm going to use that SDL window pause centered. Is that what it's called? SDL window pause centered. It's going to calculate for us to make the window centered. It's going to figure out where the X and the Y needs to be. So SDL window pause is one word, and then centered. I believe it's like that. Hopefully, it'll tell me if it's wrong. SDL, and we got that same one down there. And then for the width, we're going to use our own what we've created, which is window width. And bring this guy around. Window height. And we have our flags, which is the Windows flag. Okay, so this isn't correct right now because we haven't given it a name for the variable that's going to hold it. So we'll just call it win for now. So that should be correct now. So we got our title. We're saying use window pause centered for both the X and the Y. And we have our own width that we've defined up here and our flags that we've also defined here and our title that is defined here. Make sure when on these pound defines that you don't put a semicolon. I accidentally do it all the time. And then I end up with buggy code because it won't work when you put a semicolon there. So if this fails, what we're going to do is we're going to check to see if this is a populated pointer. If this function fails, it returns a null pointer. So all we have to do is check to see if this is null. So we could say like this. Sorry. We could say if it's null, like that, right? Or we can be more explicit about it and we can say null, like that. And we need some kind of error message and to get out. So we could just grab this right here, yank it, put it in, right? But I actually want to do SDL quit as well because SDL is up and running. So if we have to shut down here, we should do SDL quit right there. And we need to change this error message. So we'll say error creating window, and we'll still get the error message from SDL. Okay, so we have SDL up and running, hopefully. Then we bring in, we're creating an instance of a SDL window here, making sure that it is, in fact, not null. And so the reverse to this, the last in, first out, would be to destroy this window. So right here is the function. And this is SDL destroy window. We pass into the pointer to the window, and it returns nothing. So let's just grab this function. This is freeing the heap allocated memory. You can't just use free on it. It could have other things in it that are done differently. You don't know what's happening under the hood, so they have a function that it's doing all that for you. Okay, so down here, before we do SDL quit, we are going to run this. And we just called it win for now. So win. And I don't like tilling a dangling pointer. So I'm going to say win equals null. Okay. Because we've just freed the memory allocated to win, but it's still holding the pointer address. So we need to set it back to null. Just I know we're exiting right now, but just anytime you free memory, you should just right away make sure you set the pointer back, because at some point you could just add more code in between and then try to dereference that pointer that is a dangling pointer now. So you don't want to do that. For up here, we're doing the quit. We don't need to. There's no pointer for the SDL in it. So, okay, so we have our window. So right now, if we were to show this, for one, it wouldn't not work in Mac, because Mac systems need you to have some kind of input, or they don't show the window at all. So if you're on Mac, unfortunately, you can't compile and see something happening right now, but in Linux, we can. And at least on my system. So we can see that it's not going to be correct. Okay, so let's just do that. I'm just going to get rid of these. And I'm going to use a delay, because I don't want it to open and close immediately. I want it to open and stay open for a little bit. So I'm going to use SDL delay. And it's in milliseconds, so I'm going to use 5,000 milliseconds. It'll make it 5 seconds. And again, I do not think this will work in Mac, because what happened is it won't even display the window. So we'll put 5,000 here, but that's fine. We're going to get to where it works on Mac in a bit. You just have to hold tight. Whoops. Okay, so we have this. So now how do we compile this, right? Because we did bring in this SDL2. So we need to make sure that we're doing stuff with this. So on my system, it kind of knows where everything is. So if I were to tell it to delete this main that we made, so I'm going to say rm main, and then if that's successful, I'm going to say gcc source /main.c, right? And I want the output file to be main. It's the output. Now, if I compile this, it's not going to work. So let me just show you that it doesn't work. And because we need to link against, right? It doesn't. It's saying it doesn't know where these things are defined. It needs to link against the SDL library. So the linker is like failing here. So what we really need to do is go -L SDL2, and this should work, right? It's just saying couldn't remove because I'm chaining these. The file didn't exist, so it's, you know, there we go, and it's been compiled. So now, if you were on, say, a system where you weren't quite sure where the library was, or it was complaining you didn't know where the header file was, what you could do is use those commands that we were doing, this pack, right? This one. We could just copy these directly and drag them in, or we could just use variables. So we could do this right here, where we could say, you could, like I said, you can copy and paste too, but we could just do this package conf C flags, and then SDL2. And that'll get where the header file is, but that won't get the linking of the library. So the linking of the library, and they have to be put in separate. I know you can output them together, but it doesn't, in the command, it will not work. They have to be in separate. So the package conf, and we'll say libs, and this is the one that's going to produce the -L SDL. Okay, so if we just do that, because they could be on different places in your system, and this is going to hopefully package config can find where they are in your system, and that worked. Okay, so if we run this, we get this window that opened. It's going to stay open for 5 seconds, and it's not drawn correctly. It's all messed up. And that's okay. That's exactly what was supposed to happen. So nothing's gone wrong there, because we haven't done anything with the render yet. So that was the expected outcome of that. So let's keep moving forward. So we got the window open and destroyed and all that. So the next thing we need to do is make a render. The render is kind of our canvas that we paint on. So like you said, that inside the window, it wasn't being drawn correctly because we basically didn't have a canvas. So we need a canvas to paint on, and we also need to actually clear the canvas and display the canvas. So just creating the render won't be enough. We'll need to actually run 2 functions on the render. So let's just grab this function. This function takes a pointer to a window, and it takes an index and some flags. So the pointer to the window is what we've already created. The index is -1 for, it's going to use its first one supporting the requested flags. So we're going to use -1 on that. And then I'm going to click this to see what these flags are. And I'm going to use the accelerated one, this flag right here. I think if you don't do anything, it automatically tries to do accelerated anyway, I believe. So, and again, if you're on Mac, you might have a software render, but it's still going to be fast, but like won't be as fast as Linux because I think they just use Metal, and I don't think they use OpenGL anymore. But it does seem like the performance is about half as much on my son's laptop than my Linux machine here. Okay, so I'm going to go back and put that, and then I'm going to come and grab this function. So since this is a render, I'm going to have render flags. And then we'll go grab that function right here. Okay, so underneath the window. Okay, so this function is returning a render, and I'm just going to call it ren for now. And it takes a pointer to the window, which was called win. And we have that index, which we're just going to use -1. And then we have the flags, which we have put up above as render flags. Okay, so this is returning a pointer to a render, and we're going to check it the exact same way that we checked the other one. Okay, but this one, make sure we change this win to ren. And the message should be error creating render. And we're still going to use SDL get error. That's fine. We're going to quit SDL, but this time we had the window already allocated. So I'm going to go down here and I'm going to grab this guy right here because I want to destroy if we get to here and the render doesn't get created correctly and we're bailing out, returning, before I shut down SDL with the SDL quit, I want to close that window. Okay, so I know this looks ugly. We're going to make this better later. This is just like the basic thing. So we have that window, and guess what? To destroy the window, it's exactly like destroying a window. Or yeah, destroy the render is just like destroying a window. I don't really need to show you the page. It's the exact same thing. So it's going to be SDL destroy render. And we just put in the pointer to the render, and then we're going to set that to null as well. Ren null. Okay. So if we compile this, we're going to get the exact same thing that we got before because we actually are not showing the render. The render exists, but we're not displaying it yet. So I'm not going to compile it because, again, it's going to show the exact same thing that we just saw. So what we need to do is clear the render and present the render. So we've done this destroy render. It's exactly the same as the window one. So here is SDL render clear, and this does return an int. 0 on success, but I actually don't check this one because it's in the game loop as a render. It's not a loading of a resource. So I don't worry if this fails or not. I'm going to let it go right by. It doesn't matter if it failed. It's not catastrophic to the game. So I'm not checking the return on this. I do check the error on almost everything, but when it's inside the game loop and it's showing something on the render, I just let it go by. So this is SDL render clear. So imagine you have a canvas, like a painting, like you're doing a painting on a canvas. So nobody has seen this canvas yet. That's your render, and you clear it. So like, let's say that maybe there's some stuff that was painted on it before, or you started another project, but you want to start a new one now. So you either paint it all white or black, or you use some cleaner on it to clear it. So this is going to, if we haven't set a color, it's going to clear it to black, but still nobody gets to see it because it's still a hidden canvas. It's still a hidden painting. And then when we do SDL present, we're going to show it. So we're going to run these two functions, and this one has no return. Both of these are taking render and nothing else as a thing. So I'm just going to run these two functions, which is SDL clear and SDL present. Now you don't actually have to run clear. You can just run present, but whatever was on the last frame will still be drawn, and the new frame will be drawn on top of it. So you get like weird streaking stuff. So, I mean, if that's what you're looking for and you want to do, then you can just not clear it. But otherwise, you probably want to clear the render. So we'll do that here. So the first one I'm going to do is SDL render. Sorry, it's just render, not renderer. Clear. And we put in the pointer to the render, which is ren. And I'm not checking anything on that. And then we do the present, which is ren as well. And I'm not checking anything. That doesn't even return anything. And we're going to stay open for 5 seconds. And this still will not work on Mac because we need to check. We need to check input of the events. We need to check events before it shows up in Mac. So this will not show up in Mac yet. Okay, so I'm going to use the same exact command. I'm going to delete the file first. Main, and we'll put a logical and. Okay, main. And now we have a black window. So before it wasn't rendered correctly inside, but now it's okay. Okay, so let's get to the part where we're not open for 5 seconds and it actually will show in Mac now. So all this is good, but now we're going to talk about unions. So events are unions. It's a queue of unions. So union is a container that holds just one item, but you could put 1,000 different items in it, but you only put one item in it at a time. It just holds one item. So it's like a box that holds one item. So like a struct would be like a bookshelf or something like that, where you could put lots of different things in it at once. A union is just one box. You can put one item in it, but you could put 1,000 different items. The box just needs to be big enough for whatever the biggest item is. So this is really efficient when you're size constraint or you want speed and other things like that. So an event is a union. So it could be one of these things, but we don't know which one. Okay. So the first thing we do is check the type. So there's an event queue. So what we're going to be doing is, as we pop each one off the queue list, it's going to give us one event at a time, and we're going to check what that event is. And it's going to exhaust the queue of events. So every time we go through our frame one time, we come back up at the top, we're going to go through whatever our waiting queue of events that SDL has waiting for us, and we're going to go through all of them until they're exhausted. And then we're going to update our game and draw the frame, and then we're going to come back around and look and see if there's any queue of events again. And this could be keyboard inputs, mouse, closing things, changing the size of the window, all kinds of different things. So it could be any of these things here. So just know that it's a union, and we're going to, yeah. So we don't need to create this. Well, we can create it. Yeah, I usually hold on. So let's just create the event. I didn't open up the function that queries. Yeah. Okay, so basically, before we do this rendering clear, let's get the events. We'll call it event. Yeah. I will say while, I think this is SDL get event. Pretty sure it's get event. I should have pulled it up. Hold on. Okay. I'll just look at my other code. It's got to be SDL get event. Query event, queue event, pull event, SDL pull event. Sorry. Just had a thoughtless moment. So, and we're going to put the address of this thing in there, because this is literally just an event. It's just that union, right? And we're not going to pass in a copy of the union. We're going to send it the address so it can populate it. So this is the actual event, if I could spell, here. Or you could put E there if you wanted. It doesn't really matter. You can call it whatever you want. But here, I'm going to send in the address of it. Okay. So while we're doing that, we have to think about what kind of event. And for this, we just want it to look to see if we're quitting. If we've asked the window to be closed, that's enough. That's enough for us to not have this 5-second delay before it closes. We could just leave it open forever until we tell it to close. And also that's enough to get it to show up in Mac. So let's go back to the events. And we have all these different events, and we're going to check the type of the event. But the event that's important to us is the quit event. So there is an SDL quit event. I think it's down here, bottom. It's right here. This is the one we're looking for. And this, I mean, there could be different things that cause the quit event, but we don't care what it is. If the type of the event that we're looking at is SDL quit, we're just going to go, yeah, let's quit. That's a good idea. So we don't need to look any further at it. Once we know the type of this event is quit, we don't need to look into the event at all. We already have enough information. It's quit, so let's quit. Okay, so I'm going to do this one. Just looking at this real quick. So this is what we're looking for. Not this user. Seeing if they're documenting it here. They usually have lots of good stuff. Okay, so let's go back to the code. So we're going to switch on the type. So we'll say it's not case, it's switch. Switch. I will say event dot type. And then here is going to be case, and it's SDL quit. Sorry, it's all capital. That one right here. And we want to shut down basically if this happens. So what I'm going to do is I'm going to put a sentinel and I'm going to wrap this whole thing. So I'm going to put this in a while loop because I want this to spin. I want it to, like, this is the game loop. I want the game loop. I want the first thing to do is we check events, and then next time we draw and delay and all that. So I'm going to put a sentinel up here. It says like playing or something, or running. So we'll put bool running and running here. And I'm going to set this to true. I should have done that. So it's set to true. So while this is true, we're going to be in our game loop, and our game loop's all going to go all the way down to here. Oops. Not the one I wanted. Okay. Spelling everything wrong. For bools, we need std bool. Okay. And let's go down here. I'm sure I've made something take care. So we have this. This is our game loop right here. This while right here, while running. And here's the end of our game loop, and then it's cleaning up. So since we're talking about a game loop, we don't want our loop to be 5 seconds now. We want it to run roughly at 60 frames a second. So what we're going to do is we're going to set this to 16 milliseconds, which is roughly, it's not exactly, it's roughly 60 frames a second. So we'll put that. Okay, so what we've done here is we have our switch. We have our case. Right? And we got to set up what happens now. So since we have this sentinel value right here, I'm just going to change that to false. Okay, and I need to break. And also what I'm going to do here is I'm going to put a default, because depending on how strict your compiler is, it will not like this. And usually I run on very strict settings. So I'm going to say default and just break. Okay. So we're bringing the window online, the render online, and here's our game loop where we're checking events. seeing if any of them are quit. If there are anything else, it's just ignoring it. It's only checking the type. If the type is quit, we're setting this. Anything else, nothing's happening. When it gets done with that loop of checking all the events, then it's going to go clear the render, present the render, and then it's going to delay. It's going to delay for 1/60th of a second, roughly. Okay, so if I haven't made a major mistake and this compiles, this should work in Mac as well. So we'll say rm main, and then we'll do the same. I'm just going to get rid of that. Okay. And we're running main. And now this is open. And if I hit the X right here, it's closed. That's cool. So I want to clean this and restructure it. But before we do that, let's go one step further with this pulling of events. So I just want to say, make sure that everybody understands this. This right here is saying we're going to have a union. It's going to be a box that can have many different things. One of, whatever is an SDL event can be in this box, right? And whenever you pass anything into a function, you're passing a copy of that thing into a function. But I want to actually change the real box. So what I'm passing into this function is a copy of the address of this box. So if the address of this box is like in my living room, and I write down on a piece of paper in my living room, and I give it to this function, and this function makes a copy of that piece of paper that says in my living room, now it still has the box. It's looking at the address of it. It's still in the same place it was always at. So everything in C is copied by value, which is a copy of it. But since we're sending in the address, we're copying the address of it, which gives us the real thing inside the function. So this function needs an address. If we look at what it is here, see, it's a pointer to an event, which is the sending in the address of this event is a pointer to an event. So, and now this loop is going to go through all the events that have been queued one by one. And we're just checking the type of all of them. And if one of those types is SDL quit, we're breaking out of this loop, and it cleans up. When it breaks out, it goes to here, cleans up the render, cleans up the window, shuts down SDL, exits successfully. Yeah. Okay, so let's add one more thing. Let's go back to these. We have these quits, the SDL quit, but we can also look at like keyboards, right? So up here we have SDL keyboard event, key, right? So if the type is key, I'm going to say this wrong. Let me scroll down here. I'm confusing myself with it. If the type is SDL keyboard, key down, or something like that, forget an SDL2, it is key down. So if this is the type right here, that means what's in my box is a key event. Okay. So, and it's going to be .key now, but we can open up this page, which I have open here. And this is what the union looks like now. And inside of this union, there is another box. And I don't know if this is a struct or a union. It's not really important. So right now we're at event.key. And this would be key sim. And if we look into that key sim, it's another box, or it's a struct. And we have a scan code. If we look into that scan code, we have all our keyboard scan codes. So what I'm going to do here is I'm going to use the escape key to also quit. But setting up setting it up to look at keys will mean you'll be able to add another key whenever you want to. It's very easy. Once you have the first one, the other ones are just the same. Okay, so just remember that there's that whole kind of, we need to look at, once we have the type that is a key down, then we're going to go key sim, scan code, and then we can switch on the scan code. So what I'm going to do here is we have two cases right here, or one case and a default. So I'm going to put a new case here, and this time we're going SDL key down. That is the case we're looking for. And if we end up inside this case, I actually want to run a new switch statement, right? But I want to run it on the scan code. So what I'm going to do is I'm going to say switch And I'm going to switch this time on event.key.keySim.scanCode. And we'll say case. And this time, the case I want is, they're all here, but I can tell you the one is escape is what I'm looking for. So let's see. Escape, yeah. So it's SDL key escape. I don't know if there is a short for it. I think it's just escape. So I'm just going to copy that one, put it here. I don't know why these aren't lining up. Okay, so what I want to happen if this is triggered is the exact same thing. So I want to say running equals false. And I want to break. Whoops, wrong spot. Break. And I want to put a default on this. It should be inside the bracket. And just put a break on that. Hopefully I've done that all correctly. So now if I tell it to close by whatever method, like Control-C or whatever the way that you tell things to close, or by pressing the X, it should close. But also if I press the escape key, it should also close too. So let's remove the old one, and we'll rebuild the new one and run it. Okay, so this time I'm going to press escape key, 1, 2, 3, escape. And I'm going to press space key, K key, L, up and down arrows, nothing's happening, and escape. Okay. And make sure the old escape works right there, and that works. So now that all should work on Mac and Linux as well. So you should be good with all that. So now I kind of want to clean up this code, because this is not the way you want to do this. This is, this is pretty ugly. It's not really organized. So I kind of want to clean it up. I do want to look real quick if what I named things. I think I named it running, but I just want to double check in my code to make sure I'm naming everything the same. Is running is what I called it, and I did call it event. Okay, cool. So what I want to do for this one is I'm just going to make a basic, let me get back into main, sorry about that. I want to put all the game kind of objects in a struct and pass that struct around. So the only two things we have right now is the render and the window. So I'm going to put those two in a struct. So we'll call this struct game. Yeah. And I want an SDL window, and I'm going to call it window this time. And it is a pointer to window, so I'm putting the star there. I need an SDL render. And it is a pointer to a render. And I have this bool is running, and I also have now you can see down here that I'm kind of right here. Every time through this loop, I'm recreating this. I don't need to do that. I'm just going to create it once and hold on to it. I don't know if it's optimal or not, but I just feel like that's probably a good idea. So I'm going to do that. So that's SDL event. I'm just going to call it event. It's not a pointer. It's just an actual event. And I called it is running in my original code. So it's a bool, and it is running. So that's going to be our container. And I do need a semicolon right down here. Okay. So we have this container. So now we can, use it. I'm trying to think of how I'm going to pull all this code out. I know what I want at the end, but I don't know how to get to that point the smoothest way. So I'm just going to make an instance in the main function of this game, because it's this struct. It's not very big. It's just 2 pointers and a bool and an event. So I'm just going to do that. I'm going to call it game. Just say equals. I'm going to put a 0 here, and it's going to give me the struct with everything zeroed out, which means these pointers will be null, event will be empty, and this will be false. Okay. So this is, instead of having garbage data, I'm getting it all zeroed out. And for pointers, zeroed out means null. So that's a nice way to start things off. You don't want garbage data in there because if you have something uninitialized, you won't realize it, and it could be very bad. So if we have these right away, I can kind of use this one right here. I can say game dot. This one is window. Yeah. Game dot window. Yeah. And for the render, and down here, okay, it's going to complain. We're going to end up changing this again. Here needs to be game dot window, and here is game dot window. Here is game dot window. Okay, I'm sure there's some other places here. For this guy right here, and this guy, this is game dot is running. This is game dot event. Game dot event. And this is running. Okay, so render down here in window. So hopefully this all still works now. Hold on one second. Okay, so that didn't work. So something's wrong there. Or I've made a mistake somewhere. Let's try it one more time. Okay, so what did I do? Oh, I know what I did wrong. So I actually didn't do anything wrong. I just forgot to do something. So is running is a false by default, and we never set it to true. Yeah, right here we didn't set it to true. So it was coming right out of the loop immediately. Okay. Now I still don't like the way this is set up. So that was kind of like one step. So we have this guy right here, and everything's in the main function. Don't really like that. So I kind of want to take everything that's initializing SDL and put it into a function that is called game init SDL. Still kind of dealing with the game, but I want to put it in a function. So anything dealing with game, I'm going to call it game, and then whatever it is. So this is dealing with the initialization of the window all the way down here, the render, yes. So right down here, all of this is I'm gonna yank it, or yeah, not yank it, but cut it. And I'm gonna put it into a function called game. Now it's gonna return a bool. Yes, it's gonna return a bool. So it's gonna be bool game init SDL. And it's gonna take a pointer to a game. So struct game.g. I've just used G for what do you call it, brevity, or for to be simple and concise. I know I'm in a game function. Everything G is going to be that game. And I'm just going to paste those in real quick. Now, everything is this G. So this game doesn't work and this dot doesn't work now. So all of these need to be G with an arrow, because it needs to dereference that pointer to that. Okay, so I need to do that with all of these. And the render. And I also don't need to, so these are going to be cleaned up a little bit too right now, where I'm kind of destroying this thing twice. I don't need to do that. Okay, so, and this needs to return a bool. So we're going to say true. And this is still not right. What I want is the cleanup right here. I want this as in a function as well. So I'm gonna cut this out and bring it up here. This is going to be void. And I'm going to say game free. And it's going to take a pointer to a game. This is remember, everything's passed by value. So if I pass this in, it would be a copy of it. I want to pass in the real thing. So I'm passing in the address of it. So it takes a pointer, I pass in the address. Game, and I'm going to call it G because I'm in game, everything G is game. So this is how I'm cleaning up things, right? So the very first thing I want to do before I even try to clean anything is make sure this G pointer is real. I may have passed in a null value or something like that. So I'm going to say if G, right? If G is anything, it's not null, right? So I'm going to do that. And then I also want to make sure the render has been populated. I don't want to try to free the render if it's a null pointer already, because it depends on what part we're in. Let's say I try to initialize SDL and that fails, and I run my cleanup function, and my cleanup is trying to free the render that hasn't been allocated yet, and free the window pointer that hasn't been allocated yet. So what I'm going to do is I'm going to make sure that they have been allocated, then free them, because I don't know if they have been or are not. So I'm going to wrap these as well. So I'm going to say if G render. So if it has been allocated, I'm going to free it, which is here. And then, this is a G render. And then I'm going to set it to null, which I already have here. Okay. And so that's the way I'm going to do both of them. Oops. This is indented here, and this should be indented. Yeah. So the same story with the window. G window. So this allows me to call this function no matter how far into the process I get. I can just call it at any point, and it doesn't matter because it's going to check to see if these things are real before it even tries to free them. So even if I never even created this, the G doesn't exist or something, it was never allocated. It doesn't work in this one, but like in a future thing when it's heap allocated, it doesn't matter because the first thing it does is check to see if it's real first, and then it checks to see if those are real before it tries to free them. Okay, so I have the render freed. So it's a last in, first out. So the render is the last in. And we have the window. And then we need to take care of SDL itself. Oops. I have my LSP trying to help me out here. I just want to tab it in. And then I'm going to give myself a message. I'll say all clean. Just so I know that like my function was run correctly, I know what's going on. So this is my cleanup, okay? So on this function now, whenever anything fails, I don't need to return from this. I'm going to run this cleanup, and I'm going to return false, okay? So in the very first thing, I have nothing allocated yet, so it doesn't matter at all. But instead of returning exit, I'm returning false. Okay. So that's on the initialization. Nothing has been allocated. I don't need to do anything. But when I get to the window, still nothing has been allocated. If a window fails, I'm going to run. No, I don't. No, nothing's been allocated yet. Yeah, but I do need to run the function because I have started SDL up. So I'm going to say game free and pass in the G. Okay. And then I'm going to return false from this. So this is returning a bool. So here I return false. But if it passes this, I got SDL in line. So now I'm going to use my function up here, which can figure out to shut down SDL, but not worry about the other two. Okay, that deals with that. And now if I don't have to deal all this stuff now, what I can do, don't need any of this. What I can do is just say game free again and false here. Because now the window has been allocated, but when it goes up here, it says, yep, G is true. This is not true. This one's true. It frees it. And now it shuts down SDL. Okay. And this is G is not heap allocated, so I'm not worrying about that right now. So yeah, so as we build more and more, it just looks like this. It never gets bigger than this. We don't have to add 15 things up to shut down in reverse. We just say, tell game to free itself, and then we'll return false. Okay, so that's the way we're doing that. So here we want to initialize. So I'm going to send in the pointer to this. So this is game init SDL, and I'm going to send in the address of game. Okay. Now this can fail, so I'm going to check if it did fail. So if something bad happened, then we are going to, we don't need to print any message because our messages have already been printed wherever it failed. But what we do need to do is exit. So we return exit failure. Exit failure. So we'll just do that. So that we're initializing SDL. Okay, so now we can put this, we could put the game in its own thing, but we could actually just put this guy right here, the thing that's checking our events. We can put it into its own, thing as well. So I'm going to do that, and something's wrong here. This one, I need it all the way to here. So I'm going to cut this out, and I'm going to bring it up here, and I'm going to make this void because nothing's failing, or I'm not checking failure for anything on this one. So it's just going to be void game events, something like that. And we need the struct game pointer to G, or G is a pointer to a game struct. Read it backwards. And so now we need to change these guys. So this G, that. Every one of these spots. This will be the last time we're changing all these. I just didn't know how to get from A to B here, how to kind of show the. Okay, so this is our game. We're not returning anything from here, so it should fix our indentation. That's how we're going to check the state of things. And this is just changing this game is running, which is fine. So we can still use this game is running. Yeah, we can still use it like this. So I'm going to pull these out and call them game draw. Say void game draw. And I'll just pop those two in there. And this is a void, so it's not returning anything either. And we just need to change those games to G. Okay, so we have these functions. So in our game loop right here, we are setting the is running here. We'll probably change that in another place, but for now, this is fine. So what we need to do in here is we need to check our events. So we have that game events, and we're just passing in. Oh, I see. Because we're still looking in the main loop. Sorry, I'm going to make another function, and this function is going to be dealing with drawing events and everything else. I still think it's void. We're going to call this update game run. We're going to call it game run. That's what I called it before, right? Update run, draw. It's run. It's called run. New and yeah, game run. So we're going to make this guy right. So void game run, and this will be struct game g. And what I want to do is put the game loop in it, which is this loop right here. Well, part of it, or we're missing some stuff from it, mostly there. And so we can still set the game running on the top of this. That'll be fine. And this is now G, like that. And so we can say game events G. And then right now we don't have anything that's updating anything besides the game events. Oh, updating any logic. So we don't have an update function, but we do have a draw function. So it's game draw, and that G goes in there. Okay. So basically, main in another video will be in its own file. So here we are saying make this, and then we want to run game that I didn't spell right. Yeah. Okay. So what I want to do is actually, I'm going to change the logic around to this. So I'm going to make the exit success and exit failure by default. So up here, I'm going to say int exit status equals exit failure. That's the default. And we got to get to the happy path. So if this is successful, I don't want to exit. I want to continue on to the next phase. So I changed that from a bang. I removed the bang. So if we are successful in initializing the game, I want to run the game. So I'm going to say game run. And the game run doesn't return a bool right now, so it's just going to run. So whenever that gets done, then I'm going to set the exit status to exit success. Later on, this will be a bool, so that this will be buried even deeper. Basically, if anything goes wrong, if I don't get to this point, I'm exiting false. So I'm creating a zeroed out version. I am initializing the game state. I'm running it. I'm setting it to success. And so the last thing we need to do is clean up. And this is returning exit status. So coming out of here, if this fails, I need to clean up. So, and if it comes out successfully, I still need to clean up. So game free, and we have the pointer to the game. Yeah, the address of the game. This needs a address of the game as well, because all of these use pointers everywhere. So this looks nice. I want to try it just to make sure I have no bugs, and then we need to we haven't defined any we haven't forward declared the function. So I just want to make sure it runs real quick, and then we'll forward declare the functions. Okay, it looks good. And I can close it. Yep. Okay. So if we use a strict compiler, it will not like this because we didn't declare any of the functions that we were doing. So what I'm going to do is I'm just going to forward declare all of these. So I'm just going to yank that, paste it, and put a semicolon at the end, and the next one. Okay, whoops, that's not a semicolon. It's the event. Draw. All drawing will take place between those two clear and present functions. So when we're down here in the draw, all the drawing is going to take place here. And I'm not forward declaring main. Technically, you only need to forward declare if you need to know about this. Well, I'll show you the technically. You're right and not right, because I use strict compiling rules, so it would not compile if I did it. And I'll show you what I mean. So we are in source directory. I'm not sure if I can even run this without a header file against the main file. Let me find out. Okay, so let's take out these, and we'll use my make file and see. Missing prototype. So you can do a lot of things, like you can get away with doing a lot of things, but it's not necessarily a good idea. So I always run when I'm using I always use a make file, and I try to throw as much strictness into it as possible. And I have different versions, a debugging version and a release version and whatnot. But it won't let me get away with those shenanigans, But it reminds me, yes, I should forward declare stuff, because you never know when a function may be out of order, or maybe you may have maybe you need to declare it, to use it externally or whatever. But yeah, so like technically you don't need to. It depends on how you're compiling it, but I'm used to doing it all correctly. Plus, I don't know how it would run on Clang, because Clang and GCC, they act differently, and Clang acts differently in Linux than it does in Mac. So yeah, probably yeah. I'll show you my make file. Let me just undo these. So I want to make sure that like I'm doing tight code, and that like also it's going to run on everybody's system. So if I'm very strict with it, maybe it'll work on somebody else's system loosely. Like, you know what I mean? Maybe it doesn't work the strict way, but it'll at least loosely work. So let's see. Why am I here? Over there. So this is the make file that I'm using. And I kind of use this on like all of my projects. So I have this thing where basically I have strict rules in place. And if I build as release or debug mode, I use the strict rules. If I don't use release or debug, I don't use the strict rules. So these are in play whenever I'm doing release or strict. You can start learning C with what I'm doing here. Like basically, the reason why I made this course is because I too learned C, and then I was like, well, how do I actually build something after this? How do I put something together? I don't know how do I actually structure data and stuff like that. So that's literally what this is for. So I didn't start from the very beginning. I didn't tell you what a function was and stuff like that. So if you just watch some simple tutorials and do what is a variable, what is a function, what is a pointer. But if you just know some basic stuff, you can follow this course. Like I haven't explained anything complicated here, I don't think. Where is it? This. So that's what kind of why I was building it up step by step. And I haven't even heap allocated anything yet. So it's like you should be able to follow this. And I've even explained, I did have to restart this video like 3 or 4 times now because of technical problems. But in one of the versions, I explained where this comes from. It's in standard lib. And it's just because whenever you exit, you can use 0 or 1, but it may be different numbers on different systems. So I'm just using the macro so that depending on what system you're on, it's more cross-platform. This make file is not strictly needed for this project at all, because I that's why I was just showing you to run GCC at the bottom. You do not need to use this make file. So down here, you would just use Clang or GCC. You could just say Clang source, the very minimum main.c, and the output is O. And for my system, that's just the output file. So I want to compile the C source code and I want to output a file named main. And since I'm using SDL2, I do need a link against the library. So I do need a -L SDL2. That's the bare minimum I need on my system to compile this. And it should work, yeah. And GCC will work as well. Either way, and then I can just run main. Right? But you can also use that make file that I used as well. Yeah, I was getting paranoid with it. I was like, if I'm gonna, for one, I wanted to make sure that I wasn't gonna make any mistakes, so I was in like paranoia mode. But also because I was showing it to other people, I was even more paranoid. I didn't want to tell somebody the halfway method of doing it or something like that. And this video, the original version of this video from like a year ago, is the very first video I ever did, and it's hard for me to go back and watch it because I was like, oh, I would not code that way now. So that's why I'm re-recording it, and because I've added lots of features, but I'm also writing my code much differently. And all of them were all single files back then as well. So did you watch this? Did you watch the old one, the original C SDL1 from like a year ago? Because that's the for me, I was like, I didn't like the way it was structured. That's why I'm kind of redoing it. So in another video, we're going to break these out, and they're going to be heap allocated, but differently than I've done in my other videos. And they're going to be separate files to make it a little bit easier to deal with. You know, like right here, we have all the different files. And I kind of made it where like you can just make text objects. You can just have this one text file, and now you can just make text objects of any size that you want, and you can tell them to update themselves with new strings and everything, and they just kind of does it for you. So once you've kind of learned to do it one time, now you can just chuck it in your project, and it's got a lot of functionality. It even does little bubbles around the text if you want, stuff like that, and you can change the colors, and you can kind of think of it as an object. It's kind of the way they did it in SDL3, except I think mine has more functionality than the SDL3 had. Has or whatever, the SDL3 version. Yeah. And like the FPS one, once you've made this, you can just drop this into any system you have. Like, I don't know if anybody's seen my Bash version of this. So if you wanted to write Bash, let's see. So if we were going to do the beginner's guide in Bash, how would we do that? I think I have one in here in the examples. So this is beginner's guide in Bash. So if you were writing Bash, this is what it would look like. And let's see if we can run it. Examples, beginner's guide, and we'll say pipe. And this is running in shell. It was a bit loud.
ZSH. ZSH.
So this works in Bash or ZSH, basically. I haven't made the window resizable, which I have to go back and do that. But that's all implemented in it's written in C, but like that, what you just saw is in Bash. So this is like a bridge, a Bash to C bridge. So you can send these messages to a C server, And you can get some pretty good FPS. Let's see what the FPS was on this. So it's still running like 1500, 1600 FPS, right? That's not bad. I can lock it down to 60, but I was just wanting to see how fast we can get it to go. And these have the same thing, the little text objects. You make them in Bash, and then you just keep using the same object, and you can change the string and everything else. And yeah, I was seeing how many, I don't know if anybody's seen this text test. So this is 200 text objects. And we could change each, and this again is running from Bash. All the logic is done in Bash. We can change these text objects to be different numbers, and we can spin them and everything else. So if we had different numbers every single frame, or if we told them to spin and they have different, every single one of these text objects has their own velocity, their own rotation rate, and they're being updated through delta time. And this one is getting around 45 FPS. So that's about as fast as you can go with 200 test objects, and doing all that to them. Yeah. So where was I? Yeah. So I forgot why I went off on that tangent. Yeah, SDL3 is not done. That thing I just showed off here, I had to stop programming this in SDL3 and rewrite it in SDL2 because SDL3 is not done yet. It doesn't work. It doesn't have a sound system work. Oh, so the stream broke on Twitch, but it's still working in YouTube. Okay, so yeah, so SDL3 is not done yet. That's why. Let's go back to where we were. And we were at this main. So we have these prototypes at the top. That's for if you have strict compilers, and it's also good practice to do that. And I think we're going to end this one here. So this is kind of structured a little bit and allows you to open and close a window. It allows you to get input and keyboard input. And the next video, we're going to do a background, I believe, and we're going to load images, and we're going to make the window resizable and things like that. So that's everything for this one. If you have any questions, you can just ask them in the below. I always try to answer if I can. And yeah, that's going to be everything for me right now. And thanks for watching. I hope you enjoyed that. And again, if you have any questions, just let me know. Have a good day. Bye.